Hi, this is Andrew Firth from the VMware Cloud Foundation Technical Marketing Team, and welcome to this short overview on storage options available within a Cloud Foundation deployment. VMware Cloud Foundation is built upon trusted VMware technologies for compute, storage, networking, and cloud management. Cloud Foundation takes this further by integrating and automating these components together for rapid initial deployment, simplified scale and day 2 operations, and full lifecycle management, which streamlines patching, upgrades, and maintenance. These technologies are the building blocks of a software-defined data center, integrating all of these capabilities into a single platform that is cloud-like and easy to consume. Today we're going to spend some time to look deeper into how storage is configured within a Cloud Foundation environment and look at many of the flexible storage options available. VMware Cloud Foundation provides flexible storage support for workload domains to satisfy a broad range of customer application requirements. Cloud Foundation defines 2 categories of storage. Principal storage is the storage type selected when creating a new workload domain. During the initial automated deployment of Cloud Foundation, VSAN is configured for use in the management domain and is what VMware recommend using in any other domain. When an additional workload domain or cluster is created, the customer is given several storage consumption options to choose from. In a Cloud Foundation deployment, we refer to the storage configured with the workload domain as principal storage. While VSAN is always recommended, customers can always choose to configure their workload domains with vVols, NFS version 3, and VMFS on FC. This flexibility allows customers to continue to leverage their existing investments in storage hardware while also providing an easy on-ramp to move their workloads and applications to VSAN when they are ready. Supplemental storage, often referred to as external storage, is the second storage type defined by Cloud Foundation. Whilst principal storage is used when configuring a workload domain or cluster, supplemental storage can be used to add storage capacity to any domain or cluster, including the management domain. Supplemental storage is supported by vSphere mainly for data at rest, such as virtual machine templates, backup data, and ISO images. It's not used for running workloads. vVols can be used for both principal storage for workload domains as well as supplemental storage. Supplemental storage options include NFS options, NFS v3, and NFS version 4.1. Also fiber channel options for VMFS and fiber channel, VMFS on iSCSI, and NVMe over fiber channel. It's important to point out that adding and scaling any storage type other than VSAN is a manual process, just as it would be in a traditional environment using hardware-based storage solutions. When VSAN isn't used, the customer is responsible for maintaining server, firmware, and drivers and plugins in accordance with the VMware Compatibility Guide. If a customer is using VMFS on FC, it is important that they also check the HCL for fiber channel array and HBA compatibility. This table here helps to clearly show the different storage options available within a VCF deployment and their capabilities. Using VSAN provides the customer with a full software-defined solution. It is flexible, quick to configure, and easy to manage. It can also be changed at a per workload level using storage policy-based management. Storage policy-based management removes the need for manual hardware configuration and potential disruption when inevitable changes are needed later down the track. VSAN is also very easy to scale, allowing you to add compute, memory, and storage together when it is needed without the need to plan up front for growth capacity. As part of the hypervisor kernel, VSAN is also fully lifecycle managed, patched, and upgraded, which is completely automated when used with Cloud Foundation. Cloud Foundation supports stretch cluster and remote workload domains and clusters when VSAN is deployed. And it's for these reasons why VMware recommends using VSAN with Cloud Foundation. VMware Cloud Foundation leverages HCI Mesh for better consumption of storage capacity. VMware HCI Mesh is a VSAN feature that provides for disaggregated HCI exclusively through software. HCI Mesh allows the administrator to easily define a relationship between two VSAN clusters. It allows one cluster to borrow capacity from another cluster, improving the agility and efficiency in an environment. This disaggregation allows the administrator to separate compute from storage. HCI Mesh uses vSAN's native protocols for optimal efficiency and interoperability between clusters. HCI Mesh delivers the flexibility in resource provisioning that many of our customers have been waiting for. HCI Mesh uses a client-server mode. vCenter Server is used to configure the remote data store on the client side between the clusters within a Cloud Foundation workload domain. Various configuration options are possible that can allow for multiple clients to access the same data store on a server. VMs can be created that utilize the storage capacity provided by the server. This can enable other common features such as performing a vMotion of a VM from one vSAN cluster to another. HCI Mesh is configured through vCenter Server, as each Cloud Foundation workload domain will have an independent vCenter Server instance. HCI Mesh can be shared between clusters within the same data center or workload domain. HCI Mesh does have a requirement that the latency between the client and server is less than 5 milliseconds. When HCI Mesh is enabled and remote vSAN data stores are mounted, users will see that some actions within SDDC Manager are no longer available. This is intentional to prevent users from causing disruption within the environment, such as deleting a workload domain that has a mounted remote vSAN data store. VCF polls vCenter periodically to collect the HCI Mesh information, and as a result, it may take up to 5 minutes for the information to be reflected in SDDC Manager. As remote data stores are mounted, you will see an increase in the storage capacity available. All of this is made possible without having to shift storage between different environments, without planned outages, potential disruptions, or decreased service levels. Cloud Foundation supports the configuration of workload domain clusters using vVols for principal storage. vVols is an integration and management framework that virtualizes SAN and NAS arrays, enabling a more efficient operational model that is optimized for virtualized environments, centered on the application instead of the infrastructure. Configuring vVols support involves a few simple steps. To begin, the customer first configures a VASA provider and creates the storage container. They will then prepare the hosts, and from here, the user can go into the SDDC Manager and provide the VASA provider details. Once configured, the user can then create a workload domain and specify the use of vVols for storage. SDDC Manager will register with the VASA provider automatically and create the vVols data store. At this point, the vVols storage is then ready for use. To realize the full benefits of vVols, the user would then implement their desired storage policy-based management policies within the associated vCenter server. And that concludes this overview on Cloud Foundation storage. Please join me for more VMware Cloud Foundation videos in this series, which you can find on TechZone at core.vmware.com. My name is Andrew Firth from the Cloud Foundation Technical Marketing team. Thanks for tuning in.